Hi, I'm Fred Wilcox, Texas Professional Inspector number 160. In this episode, I'm going to be talking about corrugated stainless steel tubing gas connector material. I chaired the committee that wrote the standards of practice for real estate inspections for the state of Texas. In the original standards, electrical bonding was covered. Bonding is simply the equalization of electrical potentials. If you don't know what that means, you shouldn't be inspecting electricity. There's really no good way to connect an appliance to a gas pipe. It just doesn't exist. Any way you can name, I can tell you problems with it. But corrugated stainless steel tubing seem to answer most of the question. One, it's very strong. It's steel. Two, you don't create a situation where you are out of bond, where you have unequal electrical potentials, where something coming between the gas pipe coming out of the wall and the gas pipe to the appliance could catch fire, or if you were to touch them, that you could get shocked or electrocuted. Stainless steel conducts electricity, therefore it is bonded. To show you this, I did a little experiment. I happened to be at a house that had a workbench right by the tankless water heater, and I could set my multimeter down and show you how this is done. I made a video of it, but the video is not very good, so we're just going to do this by pictures. In the first picture, I'm showing you the setup, that we have a tankless water heater. CSST, the yellow insulated pipe, is in between the gas shutoff valve and the water heater, and of course there's a sediment trap, as there's supposed to be. Now, many people think CSST is only yellow coated. That's not true. That's the trademark of the manufacturer. There's silver CSST and there's black insulated CSST, and there may be others, but I'm familiar with those three. So I use my multimeter, and if your inspector doesn't have a multimeter, they can't do the job. Inspectors are required to check for bonding. The easiest way is to do it with a multimeter. The hard way is to lick the ends of your fingers, touch two appliances, and see if it knocks you across the room. A little hard on the body, it's effective, and you'll know if things aren't bonded, but not something I recommend. Using an ohm meter, if I go to the hard pipe on the appliance side of the CSST, in this case I'm connecting up to the pipe threads on the sediment trap, and I go behind the gas valve to the pipe coming out of the wall, you'll see that my ohm meter is registering 0. That means there's an electrical bond. There's a conductive path. Now, the manufacturer in the code says you have to put an additional bond because of lightning. The defect of CSST has been found to be lightning strikes. When there's lightning strikes, what literally happens is the electrons have to build a bridge between all the corrugation like an accordion. And they build a bridge by the electrons themselves building the bridge, and of course there's heat involved, so the electrons burn as they're building the bridge. Once the bridge is completed, it continues to burn, so new electrons are introduced. This makes a very hot spot in those depressions, and a hole gets burned through the pipe, which causes the pipe to then turn into a torch. Well, to try and control this, the manufacturer and the code, the National Electric Code and the International Residential Code, all say you must put in a bond. It's not a bond, it's a bypass. It's already bonded. Electricity flows on the path of least resistance. So if you connect a number 8 or number 6 or number 4 copper conductor between the hard pipe coming out of the wall and the hard pipe going into the appliance, the idea, the hope, the prayer is that the electrons will go across that bond and leave the corrugated stainless steel alone. If you're far away from the strike, minor strike, whatever, maybe it works. If you have a heavy strike and it's close proximity, there's so much electricity, it's running everywhere. Yes, it's taking the most convenient path, but it's taking any path that is available to it. And as we've just seen with an ohm meter, we're registering very little resistance across the corrugated stainless steel tubing. So a number 6, a number 8, number 10, well, you can't use number 10, number 4 copper conductor between the hard pipe and the appliance It's not going to have a whole lot less resistance. Aluminum will probably have more resistance than the CSST itself. So the fact that you have the bond at the meter or you don't is not really relevant, because you're hoping then that the electricity hits the hard pipe on the you're hoping that the electricity hits the hard pipe on the meter side of the shutoff valve and doesn't really go to the appliance. And that just really doesn't happen. So when you're looking at this as an inspector, you need to be very harsh in your judgment of how that gas system has a bond. Remembering, it's not a bond, it's a bypass. With CSST, it's already bonded. Now, if you have a polymer flex between the shutoff valve and the appliance, the polymer does not conduct electricity. So you must have a bonding jumper between the hard pipe at the gas shutoff valve and the hard pipe going into the unit. I hope this helps to clarify this somewhat, and you will start watching this more closely on your inspections.